Ever wonder why some AI responses feel incredibly smart while others miss the mark completely? Let's just say that there are context trade offs that nobody's talking about. This is your host, Zachary Alexander. And today we're pulling back the curtain on one of the biggest challenges in AI implementation. These come in the form of context depth trade offs. After analyzing the results from my 30-day Agentic Holiday Express Challenge, I discovered that more context doesn't always result in better results. It probably seems counterintuitive to say that you can have too much depth of knowledge. There appears to be a context conundrum. Think of Agentic AI as a professional consultant. The more background they have about your business, the better advice they give. But here's the catch that nobody's talking about. Just like human consultants, you can load Agentic AI agents down with too much raw detail. When that happens in the real world, consultants take months to analyze the data before they say they can make a plan to fix your unique problem, resulting in big windfalls for them and tons of billable hours. Just like you don't like to waste money on non-essential billable hours, you won't enjoy spending it on solutions that are unnecessarily context-rich, ones that come with extremely high storage costs. Worse yet, storage costs are ongoing. In contrast, you can always fire the consultant. Now, for the record, traditional context management doesn't work for agentic AI systems. It's like the difference between context retrieval and context management. Think of it this way. Context retrieval is like having a perfect memory. But context management is knowing what to do with those memories. You need both for an effective context-first strategy. But they serve different purposes and require different approaches. The key difference is that context management is strategic, while context retrieval is tactical. You can also have a broken system that has perfect retrieval but poor context management. If you don't have a clear strategy for how that context should be used to achieve your goals, you're done. Back in my cloud architecture days, we used to talk about things being well architected, meaning that they provide the best business impact while keeping speed to value in mind and costs reasonable. Another way to think of it is like asking your agentic AI agent to consider every conversation they've ever had before answering even the simplest of questions. At some point, more raw context becomes counterproductive. Okay, I apologize in advance, but we need to take a short technical detour. When you're running agentic AI systems, you're dealing with something called KV cache. Think of it as the AI's working on short-term memory. What happens is each token of context needs space in the memory. According to our buds over at NVIDIA, that's currently about 4 characters depending on the AI model. The more context, the more memory needed. When the memory fills up, performance drops. When performance drops, costs rise. An NVIDIA expert recently revealed if someone maxes out the context on their GPU all the time, that should set off massive red flags for anyone architecting agentic AI systems. You should never continuously fill up the context on the GPU or graphic processing unit. Rather than discuss GPUs any further, let's just say that there's a way to have your cake and eat it too. Enter the power of the dynamic duo, Voyage embeddings and Pinecone vector databases. You can think of embeddings as numerical representations of words, sentences, or other data in lists and numbers that capture their meaning and relationships. Vector databases are specialized databases or database systems that are designed to store and efficiently search through embeddings, like those just mentioned. Now, you don't get rid of your current relational databases. Think of them as the two-dimensional data you get at no extra charge. They are the detailed reference data that drive tactical impact. That's something to think about as you prepare to implement your context-first strategy. Here's where the real magic happens, though. Let's start with intelligent context storage. Instead of raw text and nondescript images or random videos spread across the entire organization, we can convert their relationships and meaning into context that live with the data elements forever. When I talk about raw context, I'm not just talking about the data stored in relational databases. I'm also talking about the numerous data islands that exist throughout most organizations. Think of smart storage and retrieval as like upscaling an image or video. You can enhance the detail when viewing it on a larger screen. These embeddings may capture meaning in relationships that you don't even know exist. Smart retrieval refers to advanced context-based techniques for finding and retrieving relevant information that go beyond simple keywords matching. Smart retrieval uses AI and its semantic understanding to retrieve relevant content. Let's move on to the real-time optimization, which dynamically adapts retrieval based on the query context. You can use Voyage 3 and Pinecone to maintain massive context libraries with a minimum amount of overhead. You can scale without exponential cost increases. So what about performance impacts? Let's break it down for you. Memory usage. Before the dynamic dual, 100% of context needed to be loaded. After the dynamic dual, only relevant vectors loaded, resulting in up to 90% memory reduction. Processing speed. Before the dynamic dual, linear scaling with context size. After the dynamic dual, nearly consistent retrieval times that results in dramatically faster responses. So what that means is as you increase the amount of context, you don't see a resultant amount of latency. So things don't get slower. Just because you know more about your subject shouldn't mean that it's going to take you longer to actually process a request. Cost efficiency. Before the dynamic dual, costs scale with total context. After the dynamic dual, costs scale with actual usage, which results in better ROI on AI investment. What we're going to talk about now is a practical implementation guide. Here's your actionable roadmap. Step 1, vector setup. Set up your Pinecone instance, implement Voyage embeddings, and convert existing context. Step 2, integration. Connect your favorite LLM, large language model, set up retrieval pipelines, and implement caching strategies. Step 3, optimization. Monitor performance matrix, fine-tune retrieval patterns, and scale based on usage patterns. The future of AI isn't about choosing between context and performance. It's about using smart tools to get both. Vector databases and embeddings aren't just optimization techniques. They are the key to unlocking the full potential of context-first AI. Remember, every bit of context is valuable, but only if you can access it efficiently. Your job isn't to limit context, it's to manage it intelligently. Want to master this game-changing approach? Hit subscribe and join our YouTube community here at Agentic AI Express. Remember, once we get up to speed, no one will catch us.